Hey guys, welcome you all. Just allow me a few seconds. We'll start this session. Just give me 1 2 minute more. Sorry for delay. All right, I believe we are all set. Okay. All right. So I hope everyone able to see my screen. All right. Just put in chat if you're able to see my screen so we can start the session without any further delay. Let me just see where is my pen. Why it's not opening? All right, let me double click on it. Should be open very soon. All right. So welcome you all once again in the session. And today we are going to discuss a very important topic. That is the Zscaler, right? So we are going to discuss more detail about the Zero Trust Exchange, right? That's the key concept nowadays we have to understand because now things are moving very fast in industry, and if we are not going to understand, right, then probably we are going to stay behind. All right. So once again, welcome you all in the session, and I'll be your instructor, right? And I'm going to just discuss about the Zero Trust Exchange, that is ZTE of the Zscaler. So I'm very much excited because we are going to discuss the crucial topic for the modern cybersecurity. And we must know about these all things being a cybersecurity engineer or might be network security engineer, right? So we have an era where we have the traditional perimeters based security. We have the traditional perimeter based of firewalls. And by using those firewalls, we can able to protect our network. But that approach has been completely changed. And nowadays, we are discussing about the different method to protect our infrastructure. That is our end-to-end infrastructure where you have the end devices, we have the network devices, we have the ISP network, we have the application segment network, which is a private cloud, we have the public cloud, we have their own data center. And also the way of working culture has been completely changed. Earlier, we are having a culture, we have the set of the data center, might be it is setting in the some other countries as a DC and DR, and you just have to visit your office, and after visiting your office you just have to make sure your application are going to be accessible from the your office network. And if you have to access those applications from the remotely, then probably or might be from the work from home, then probably you just have to use the VPN solution, and by using the VPN solution you probably have to access your network. So this is how it is going to be accessible from the traditional perimeter based security. And that was, we have the native firewall like the Palo Alto, we have the checkpoints, we have the other Cisco FDDD or ASA firewall, we have a different dimensions of Post firewall, we have the FortiGate firewall. So why this Zscaler come with this concept that is known as a Zero Trust Exchange? That's the key concept we have to understand. What does mean Zero Trust Exchange? So if we talk about the Zero Trust, first, we have to be very much clear, right? When you're discussing about the Zero Trust Exchange, that means you have to access any application, right? And if you're going to access any application, then probably you just hide the all network information. Means you can just think about earlier how the communication was happening. Let's suppose any user want to access any application, so he have to go router by router, hop by hop to access those application. And once he have the accessibility of that application, then probably he have to send the packet even hop by hop to the all network. And even I'm the normal user, even I come to know what is happening in my network and how the packet is getting transmitted from one location to another location. And I am very like sophisticated kind of the hacker. I have the very good knowledge about that and hacking techniques. So probably this could be the very dangerous for me. Why it is going to be dangerous for me? Because I can manipulate the things, right? So to hide those network infrastructure, we have to use some concept that is known as the zero trust concept. And where Zscaler come with this masterpiece, that is a ZTE concept. And to achieve this ZTE process, we have to use a lot of platform, lot of services of the Zscaler, and then entire infrastructure is going to be secure. Okay. So if I talk about the zero trust, right? So zero trust is a framework that operates on the principle of never trust on anyone. The simple concept. Zero trust means you have to never trust anyone. You have to always verify the identity. So zero trust means you just have to make sure you have to never trust anyone, right? Simple concept. Always you have to verify. Okay, so this is a just one liner explanation. If I'm talking about zero trust, means any packet is going to process via the Zscaler. Any packet is going to process via the Zscaler infrastructure from your machine to any application. This could be your internal application. This could be your external application, or might be even the same LAN network. This is also masterpiece from the Zscaler. Even I'm going to use the, like I am in the LAN, okay? And if I am in the LAN, let's suppose this is my switch and there are two clients and they are connected in the same subnet. Let's suppose they're having the same IP address, means same subnet IP address 192.168.10.10, and this one having 192.168.10.11. So they are in the same segment. They are just going to communicate to each other by using the VLANs. But even we have the same scenario, even this zero trust going to come in a picture, and they are not going to allow the communication between these two PCs. Because that means either I'm talking inside of my LAN network, even the outside of my LAN network. Always I have to prove my identity. So this is the key concept of zero trust. Okay. So the same concept we are using in the Zscaler, that is zero trust. In SD-WAN, we are using that, the zero trust fabric, and also we are using like zero trust model concept, right? ZTNA concept. So these all are the same. Means whenever you see the zero trust fabric, GTNA, zero trust network access, that is the same concept. Zero trust exchange, that is also same concept. But you just have to might be very different platform. Prisma having a different name, Zscaler having a different name, SD-WAN if you're going to use that also having a different name, right? But if you find the word the zero trust, that is single meaning. You have to never trust on anyone, and you just always have to verify your identity. This is simple definition of the zero trust. I hope you guys understand. Just put me your chat if I'm having any doubt. So I will definitely reply those all answers, like whatever the questions you're going to ask. Okay, this is simple definition of the zero trust. What else we have to understand? Means which kind of a device, which kind of the user are going to communicate which type of application, that also you have to understand. So if I talk about the end users, so end users having what kind of devices? Might be end users are going to use the laptops. Okay, so let me write it here, some end devices. So we have the end points in the more technical endpoints. What we have the endpoints, we have the laptops, we have the PCs, we have might be some case think about endpoint as servers as well, right? We have the phones, right? We have the tablets, right? And we have other additional devices. Some devices like IoT devices, some are the CCTV camera, but not all devices always require this to go on the internet. Some devices might be just need to communicate internally. So in that case, we can exclude them. Some devices even not going to part of the Zero Trust Exchange. But yes, most of the modern devices which are going to support the internet-based connectivity, they always require a zero trust model where their all traffic must be going through the Zero Trust Exchange, and it must be first proof their identity, and they must have to verify themselves, then only this is going to communicate with the any kind of the application. So end devices, this PC, this laptop, this server, what they want to do that. So basically when you just use any devices, we have to use either SaaS applications. Might be I have to access Office 365 application. I have to access google.com in the internet. I have to use the cloud-based application. Let's suppose my Citrix server are hosted in the cloud. My SAP server are hosted in the cloud. That could be the Azure cloud, that is the AWS cloud, or might be any box.com, right? Any Google Drive.com. So these are the SaaS-based application. Also, it could be part of SaaS application. Might be you're just going to host some, I given the wrong like examples. So basically Citrix and SAP and some other file servers are going to host in the cloud servers, right? Data center might be your own data center. This also going to be part of your network. So here you can host your own servers, might be internal server if you're working for any company. So let's suppose any HR portal are going to be hosted, or might be any backup Citrix server, you're hosting their own application. So these are the things are going to happen. So your workforce are going to be here, right? These workforce must be going to communicate to these applications. All right. So if they are going to communicate with this application, so these workforce might be going to use the endpoints. Those endpoints are basically nothing. Those endpoints are, you have the laptop, you have the PC, you have the servers, you have the phones, right? Tablet, etc. Printers as well. So that means every user, every devices means your workforce who want to access the resources which is hosted on the SaaS-based cloud infrastructure, or might be SaaS provider like Office 365, we have the box.com, we have the Salesforce, we have the Google Drive, we have any kind of the other SaaS applications that must be undergo with strict identity verification, regardless from where he is coming. Might be he is working from home, might be he is working from the office, might be he's working from the airport, might be he's working from the some beach area, or might be the restaurant, might be the railway station. It doesn't matter. He always have to go with the strict verification. And that strict identity verification is going to done by the Zero Trust Exchange. And this is known as your Zero Trust Exchange. We'll discuss what are the components of the Zero Trust Exchange, but I'm just trying to make you the very simplified version so you guys can understand how this is going to be make a magic thing when the identity and other things are going to be verified by using the Zero Trust Exchange method. All right. So now let's move in the next part, right? So if I just explain a little bit more, right? So the Zero Trust Exchange, it is going to this, you can just focus about this one. Zero Trust Exchange, if you're just talking about this one. So Zero Trust Exchange basically serve as a backbone of any kind of the communication. Means this is the your user workforce, secure environment, your B2B connection, any IoT devices. It is just going to act as a backbone, or you can just say as a mediator, or intermediate devices, or intermediate cloud-based devices, even you cannot see them, who are responsible to allow the organization users securely connect the any kind of the SaaS-based internal application, cloud-based application, without relying on the traditional VPNs concept. Means how earlier the concept was happening. Let's suppose this user want to access the SaaS application. So SaaS application you have to access, then there is a lot of problem for you. Why it is a problem? Because you have to build end-to-end VPN to the SaaS providers and to your internal infrastructure, right? So somewhere might be your on branch location, You have to some VPN short of the solution where your organization need to have the peering with the another organization, might be a SaaS provider. Then you are going to securely access the application. This is the one way, or might be you have the central breakout. From there, you have the VPN solutions. From there, you can just access the SaaS resources. And also, if you're going to the internet, then also you have to use the firewalls and all. Just by using the VPN, you have to connect your data centers. And after data centers, you have the breakout of the internet. So your filtering of traffic and every security parameter is going to be applied there. Cloud application again, it is going to be internet data center again you have to. So VPN is always going to require, but the way the transition has been happen, the digital transformation we are doing day by day. If you're talking digital transformations, so that means the user are working from the anywhere, and we have the applications which are hosted even the anywhere. It's not limited to my data center or cloud itself or the internet. It could be the multiple cloud providers. It could be the Azure. It could be the AWS. It could be the GCP. I have the multiple cloud providers. I have the multiple internet destination. I have the multiple SaaS providers as well. So how many VPN I'm going to build that? And to building the VPN, doing the troubleshooting, taking the license, it's overhead and cost is going to add on also for the company. So that is not scalable, right? So VPN solution was applying the traditional VPN or on-premises firewall appliances that was not scalable, and that was not designed to tackle or handle the latest digital transformation. So that's why zero trust model come in a picture. And this is the part of the SASE. Okay. Secure access services. Secure access services. So this SASE concept, right? SASE is the framework. Probably I'll discuss more in detail about SASE. So the Gartner, basically Gartner is the, like you can think about the open standard organizations, right? Who have the technologies based ratings for the company. They build the concept, and different company using this Gartner concept to just build some products, to just meet those business use case requirement where they are facing the challenges. So let's suppose I have one problem. So how this problem is going to be sorted out? So if the problem is very new, so probably the Gartner is going to study your problem, and based on the study your problem, they are going to give some solutions. All right. So this is how things is going to work. So similarly, SASE is the secure access services that is going to be come in a picture, and based on that, you have to use the zero trust or GTNA concept, and based on that, you are going to secure your network, right? In regard of the VPNs or on premises, your firewall other solution, you just have to remove these all things. This model is going to ensure, right, the application you are just trying to access that can be accessible without any kind of the malicious transitions, any kind of the virus, any kind of data leak, any kind of the DOS protection, means DOS attacks, any kind of the other kind of the URL which is exposed publicly as the bad URL, right? DNS, IPS, IDS, even the some firewall features are going to be used there. So this is how it is going to leverage that model, and based on that, they're going to protect your network, right? So I'll give the use case, how it is all going to be happen, right? And how the different identity centric access is going to be happen, how the application segmentation is going to happen, how the secure data traffic is going to be happen, continuous monitoring analytics, how it is going to happen, which portion is going to be take the continuous monitoring and analysis, right? Everything I'm going to discuss step by step. Okay, so just stay tuned. Probably going to get more insight about this zero trust. All right. So moving next, if I talk about, if we just do a little bit deeper dive, right? What are the key component we have to achieve this zero trust section? So if I talk about the platform and services of Zscaler, so Zscaler Zero Trust Exchange is the concept, okay? But to achieve this concept, we have to use the multiple Zscaler platform, okay? And we have the three key multiple platforms. By leveraging that three platform, we can just make sure whatever the communication is going to be happen, that is going to be secure. Okay. So let me just discuss about that. So we have the three platform basically. One is we have the Zscaler Internet Access, we have the Zscaler Private Access, and we have the Zscaler Digital Experience, which is known as the ZIA. This is known as the ZPA, and this is known as the ZDX. So we can use all three platform, right? And by leveraging all three platform, by using all three platform, we can make sure, right? Whatever the traffic I'm sending means user by setting anywhere going to access any application that must be secure. That's the end goal of this three platform. We'll discuss what is the Zscaler business to business, cloud protections, deception technology that is not actually going to required for time being. Probably we'll discuss in the later stage, or some might be when you have the business communication that is going to be required. But for time being a beginner, right, or being the advanced level of the certification you're going to do for the Zscaler, we'll discuss about different certification also for the Zscaler. You have to start with these three concepts, and most important concept is GIA. We have the very good understanding of GIA, then we can understand the GPA, and the interesting tool or platform we have the ZDX. So let's understand briefly what is the GIA, what is the GPA, and how basically they are going to help to protect my end-to-end traffic when it is going to be happen from the any user machine to any application. So probably you can see this is the one of the representation, one of the diagram for Zero Trust Exchange model. And this is representing, like, when any user want to talk to any application, what is going to happen throughout this journey? We'll try to understand. So before I will explain this Zero Trust Exchange model, when it is going to access the internet, we have the use case that is known as the Zscaler Internet Access. Similarly, we have the Zscaler Private Access. We have the Zscaler Digital Experience. So all three we have to understand first as a product. What is the Zscaler Internet Access? What is the Zscaler Private Access? And what is the Zscaler Digital Experience? Once we have the knowledge of these three products, probably we can move to the next step. Okay. If you have any question, please put your question in chat. So I'll probably take those questions. I'll try to answer even. So I'll make the session as a very interactive. Okay. So whatever you have any doubt, even you can have any doubt, you can just reach out to our website. You just reach out and leave your email. You can just leave your any query. So probably you can visit this website, okay, and you can reach out to contact us, send the chat, or you can, if you want to write the email, you can just write the email as well, or you can just reach out any number. So probably we'll get back to you how the different things is working behind these technologies. Okay, if you want one session you want, definitely we arrange that also. Okay, so we have the dashboard also. This is the GIA dashboard, so I'm not going to explain much about for time being. We'll see later stage how it is going to be happen. First, understand what is a Zscaler Internet Access. That's the key thing we have to understand. So if I want to discuss about Zscaler Internet Access, this is something, one of the platform that is developed by the Zscaler, and it has been designed to secure any internet traffic. Means if any user want to go on the internet, means any user want to go on the internet, they want to access any cloud-based application, they want to access any SaaS-based application, right? SaaS apps, even your DC-based application, that GIA is not going to come in a picture, but just think about any cloud-based, any internet-based, any SaaS-based application. If I want to access by sitting in the office, then this is very important for me. This is very important for me, Zscaler Internet Access. If I am not going to use this Zscaler Internet Access, then probably if I'm just going to use the old concept based on the firewall, right, based on the VPN concept. So this is going to be, one thing is costly. Again, this scalability having the issue, we have the complexity in the network, and we having very kind of the loopholes where we have the different kind of attack surface where the attackers are going to be attacked in my network or in your company network, and they might be destroy your data. They might be destroy your reputation. So these are the insufficient in terms of the protecting your network. If I talk about the Zscaler, if you compare the Zscaler Internet Access with the your firewall and the your traditional VPN solutions, okay. So Zscaler Internet Access is designed to secure the internet-based traffic, your SaaS-based traffic, your cloud-based traffic, where that is going to be safely accessible from anywhere. And what is the most key features they have? So if I talk about the most key features about the Zscaler Internet Access, so we have the few like SWG, right, which is known as the Secure Web Gateway. Okay, I'll discuss what is Secure Web Gateway. We have the SSL inspections, right? Probably you might be heard it about what is SSL inspection. I'll discuss about that. What is SSL inspection? We have the DLP, which is known as the data loss prevention. We have data loss prevention, right? We have the cloud firewall also, which support your IPS and IDS, right? We have the URL filtering. We have the cloud app filtering. We have the browser access control, right? We have sandbox also, right? So a lot of features we have, right, etc. If I just go and show on the ZIA tenant, you're going to find a lot of feature available for the Zscaler. So let me show you quickly how it is going to look. So if I go in the policy, you can see in the web engines, this is a GIA, by the way, it's a GIA login I have, right? So I just log in the GIA admin, right? See, this is a GIA. So this is the login tenant. So you can see if I just click on the policy, so they have the web engine, they have the SaaS based security API, they have the mobile, they have the firewalls. So if I talk about the web engine, and when I talk about the web engine, basically any web traffic, if I'm sitting in the office, I want to access the internet. So my traffic, what is the web traffic? The traffic which is basically going through via HTTP or HTTPS. These are the web traffic, means the traffic which are going to work on the port 80, right? That is your HTTP. Port 80 is equal to HTTP or port 443. That is your HTTPS. So these traffic when I'm going to send from browser. So see, I'm in the browser and you are going to access any of the website, you have to type www.com, HTTP, like any website, google.com. So these are categorized as a web traffic. So any browsing activity you are doing from your browser, that is the web traffic. So that's why if you are doing the web level communication, it 99% chance you are sending the traffic, even the 99.99 point chance you have the sending the traffic on the internet. It could be via your public internet, or might be you are going to directly access your cloud-based application or any SaaS application. This could be the three use cases, right? So these all applications are going to always accessible via the HTTP or HTTPS. So that's why we have the wave engine here. You can see we have the wave engine, and this wave engine have the lot of kind of protections. Means in a security, we can do the malware protections. What is the malware protection? We'll discuss about. Malware is just something bad software, right? Any bad virus, any bad vulnerability, any bad spyware activity, any kind of the like bad bomb propagations. So anything bad which is going to harm my computer, harm my network, that is the malware. So I have to protect from those kind of activity. Let's suppose I'm doing something on the internet. Mistaken, I click one of the file, that is the virus file. Just let me go here and I just find the free test virus file, right? So if I'm doing the, see, a lot of virus file are available. So mistaken, if I click on this virus file, they are hosted on the internet and this can be accessible from the anywhere. So probably once I download this virus file, it is going to destroy my network. Make sense, guys? So it is going to destroy my network because these are the virus. So my PC is going to be impacted because this virus file are very dangerous for the PC. You can see different file, probably it is available in the downside. So you can see there is a lot of virus. This is not correct link. So if I just click on this, probably I'm going to find the virus files. So let me accept all. So you can see this is a lot of virus files we have. And if I want to download these virus files, it is going to be downloaded and it is going to destroy my network. See, this is the virus file. This is the virus file. If you click it, it is going to come in your system and it is going to destroy your network. So you have to very sure, right? And very careful while using the virus things. Okay. Similarly, a lot of attachment you are going to see as a phishing email. And if you are going to click those attachment, you are going to probably lose access of your system. Any encryption is going to be happen. Because of that, you're going to lose your system control, your data control, and it is a huge, that's ransomware attack. Might be you know that. So that's why it's very important. The GIA is acting as a secure web gateway, SL inspection, DLP, cloud firewalls, IPS, IDS, URL filtering. So you have to be very cautious while using these all things. So Wave engine having the malware protection, advanced threat preventions means anything is like very advanced. So they have the AI-based, machine learning-based sandbox features, and also have the sandbox here you can see. So ATP is just going to give the advanced level of the inspections, and based on that, they're going to stop your any kind of the virus thing which is going to process via your network or might be the any transactions. Browse secure browsing. You have the DLP you can see. So these are the key features we have. Sandbox is like something. Let's suppose I have some kind of the disease, right? But the medicine is not available. So how I'm going to be like treatment is how it is going to be happen. So for that, someone need to create the medicine, then only I can be treated. Unless I am going to be treated, my virus is going to be infect my whole body, and they might be, make me a lot of losses. Even it could be the life threat as well. Because if there is no medicine, think about the COVID. COVID was there, but there was no vaccine. So how things was going to be controlled, right? So people have to make the vaccine. They have to do a lot of researches. After doing a lot of research, they have created the vaccine, and then people are going to be secure. So similarly, we have the zero-day attack. Means we have some kind of a file that is known as the benign, right? And one is like unknown file. There's two concepts going to be used in the Zscaler. So if something is benign that I know about that, so I have that for the signatures. If file is benign, so I have the signatures. If the file is unknown, that means I don't have the signature. I have to scan them, right? So any unknown file, any unknown virus, any unknown threats that need to be checked, need to be scanned, then the policy need to be enforced, then sandbox is going to come in a picture for zero-day attack. If I want to securely do the browsing, we'll discuss more about that. Then that how it is going to happen, what is corporate browser, how the secure browsing feature is going to be enabled. DLP, I don't want to lose my any data, right? So how the protection is going to be happen, that also we have to understand. Similarly, we have, you can see, we discuss about the cloud and the URL filtering. So you can see here, cloud and the URL filtering, how it is going to happen for the monitor the cloud-based application, how it is going to happen to monitor the your URL-based applications. So these also is the very important, and you have to make sure any destination you are accessing web browsing that should be controlled, and any URL that should be legitimate, then only it is accessible. If it is the illegitimate might be provided by the company, that should be not be processed by your internet browser. Means your PC should not process that kind of the request as well. Okay. File control, if I want to make sure any data, any file need to be processed, which is really required, then only it is like PDF need to be allow, PDF need to be download, then only it is possible. If not allow, not download, then it is not going to be possible. All right. And we have the bandwidth control. I want to do the bandwidth control. That is also possible. I want to do the SSL inspection. What is SSL inspection? You can see the latest feature we have the SSL inspection. So SSL inspection is something, we have the two type of traffic as I mentioned that, right? We have the HTTP and HTTPS traffic. HTTP traffic always going to be in plain text. Okay. Means it is unencrypted traffic. But when you talk about HTTPS, it's a secure and it is also always going to be encrypted. So if any data is going to be processed in encryption, so my zero trust exchange is not going to understand what is going inside of my data. It could be the virus, it could be the malware, it could be the vulnerability, it could be the any file which is not actually need to be transmitted on the internet. So those kind of problem is going to be happen. So how that is going to be inspected, because it's already encrypted. So my zero trust exchange is not going to understand what is happening there. So to just make sure it is not going to leak any data, any virus not to be transmitted for even my HTTPS kind of the request. So we have to use something known as the SSL inspection. So SSL inspection is going to do the decryptions of your actual HTTPS based traffic. And after doing the decryption, it is going to apply the policy, whether this is the virus, this is the file, some data, and it is going to protect you. So we have the access control, we have the security, both available in the web engine. And this is all is available here, you can see. That's why I write here that all about the web engine policy. Similarly, we have the API integration for the SaaS application. So they are going to, if I am accessing any SaaS based application, I want to do the, API based control for the any third party integration. That also we can scan, configure, posture, we can do the management, we can apply the policy. We have the mobile base also app available, and I want to use for the G connector client connector for mobile. I want to scan the malware for the mobile and all that is also possible. Firewall, you can see the most important firewalls. We have the DNS control, we have the IPS control, we have the FTP control, we have the forwarding control. Basically, it's going to use the SIPA policy. Probably we'll discuss later stage what is the SIPA. So this all forwarding control, how it is going to be happen. Firewall control means which port, which destination, which source it is going to be happen. That all we are going to discuss here. Means I want to block the ICMP. So you can see block the SSH, NTP, block any malicious file. We have different allow the FTP finance team, right? You can see block the file server transfer. These all are available. Block the proxy traffic. These all are available. But if I want to block something which is not required, that can be blocked with a firewall. Even this is known as a non-web traffic. So I discussed about the web traffic. Web traffic always going to use that is going to be protected by the web engine, right? Web engine of the Zero Trust. Zero Trust Exchange. So we'll discuss, and if I talking about Zero Trust Exchange, that is your more responsibility ZIA, Zscaler Internet Access. We have another type of traffic that is known as the non-web traffic. What is the non-web traffic? Can someone put in the chat? What is non-web traffic? Anyone know about that? Non-web traffic. What is a non-web traffic? Any example? So if I talk about the non-web traffic, right? So we have the non-web traffic and we have the web traffic. So non-web traffic, basically you have the telnet traffic. We have the SSH traffic. We have the FTP traffic. We have the SFTP traffic. These are the like non-web traffic. Means any traffic which have to use the additional software to just process the traffic, like telnet as such. We use the putty sessions, any other secure CRT, other different tool we have. FTP, we have to use the different way to access. Even we can use the FTP by the browser, but we don't have to do the HTTP and HTTPS. We just have to use some kind of the IP, and then it is going to be accessible. Some FTP is also in the browser base, but most of the case we have to use software like the FileZilla. We have the file transfer software. We have some kind of the software which is known as the like FileZilla. We have the WinSFP, right? Yes, Rich, you are right. Other than 80 and 443 or 8080, these are always going to known as the non-web traffic. So anything you are sending apart from port 80 and 443 or any other custom port 8080, 8081, that all are the non-web traffic. Okay, so I hope you guys understand about that. So this is how GIA is responsible. So I was talking about the key feature of the GIA. So I'm not going to explain each and everything here. We'll discuss in some different session. We have the different section: authentication, company profile. We have some resources, VPN company, location management. We have the sub cloud feature. What is the sub cloud feature? How it is going to use? And also the root certificate when it coming going in a picture. What is the backup and restore? And also we have the nanolog streaming. So we have a lot of things to understand. We'll try to understand one by one, step by step, right? Each and everything in upcoming session. But most important thing, you just have to understand the key concepts, right? So what is my key concept, how it is going to happen, and what is the step by step process is there. All right. So moving next, if I talk about where I was, yes, I was on this slide. Let me go on that slide only. I was talking about Zscaler Internet Access. So Zscaler Internet Access, we understand they have a lot of feature. They have the secure web gateway. Basically, secure web gateway is nothing. It's just acting as a proxy. So GIA act as a secure web gateway, which is equally to proxy. So any traffic which is coming from the user, that is always going to intercepted by the Zscaler secure web gateway. And after intercepting the traffic on behalf of you, let's suppose I can just draw here this diagram. You can just think about. Let's suppose any traffic is going to come from the user machine. Let's suppose this is a user. It is going to intercept by the GIA. Okay, this is your GIA. And on behalf of this user, they are going to communicate with the application. And when the reply is going to, so one TCP session is going to bring here, and one TCP session is going to bring here. Okay. So three-way handshake is going to happen between the user and the GIA. The connect method traffic is going to be communicated. And similarly, the another session is going to be terminated from the application from the GIA tenant, whatever you have, the different services is located in a different data center. And this is how the communication is going to happen. So any traffic, it is going to come from the user machine. It is going to get fully inspected by the your Zero Trust Exchange, that is your GIA. And if it is eligible to access the application, then only it is going to send out. And whatever the reply it is coming from the your application side, it is also going to validate it. What reply you are sending to the user? Is it really required? Is it actually aligned with the company policy? If it is, then only it is going to reply back to the user. Else it is going to be drop in the your Zero Trust Exchange level. So we have the even packet flow also. Probably let me see if this slide have or not. I believe this slide not have the packet flow. Okay, we have a different slide where we have the step-by-step packet flow. Yeah, we have. See, so we understand how the step-by-step packet flow is going to be happen. When the user initiate the connection, the first thing how authentication is going to happen, then the connection tracking, how it is going to apply, then how the traffic forwarding outbound means when going to be send traffic to the application, what all things are going to be checked, and when it is going to reply back, what all is going to be checked. So we'll discuss step by step all traffic forwarding as well, which is going to give the more insights to understand the step by step process about this Zscaler. So I'm not going to discuss right now because we have to understand first Zero Trust Exchange, and then we'll discuss the specific terminologies. All right. So let me move again. So I was which slide? Yeah. So I was discussing about Zero Trust Exchange and Internet Access. So SL inspection, we understand. Cloud feature, we understand. Now we just have to understand another product. I believe everyone understand about that Zero Trust Exchange. One of the features, that is GIA. So this is for the just web, non-web traffic, and anything you are going on the internet, you are going on the SaaS-based application, you are going to cloud-based application, internet. If these all three things are there, then this GIA going to come in a picture. Now we have the another product that is known as the GPA. So what is the GPA and why we are going to use the GPA, and what is the logic behind this GPA? So if I talk about the GPA is the one of the key product of the Zscaler, and it's also part of the Zero Trust Exchange. So Zero Trust Exchange is going to consist three products: GIA, GPA, and ZDX. So if I go here, I simply go and write Zscaler Zero Trust Exchange have three features: ZIA plus GPA plus ZDX. These all three going to work combined together and they're going to form the Zero Trust Exchange. All right. It's very simple. So what is going to happen? One case, user might be accessing the application. User might be accessing the application which is the based on the internet, based on the cloud, based on the SaaS. But there could be another scenario where my user is going to access my internal application. Okay, this could be another scenario. Makes sense, guys? So I discussed about the internet-based traffic, but what about my internal traffic? Let's suppose I have the one of the SAP server which are hosted in my data center. I have the Citrix server which is accessed my data center. File server which is acted in my data center. So do I really need the Zscaler Internet Access? As a name, it suggests only for the any traffic which are going to the internet-based destination. It could be the cloud, non-cloud, this kind of solution. But let's just suppose I have some internal data center. Even I have some kind of scenario. I have the application hosted by the any private cloud data center, public cloud data center. That is also excluded for the internet access. Okay. I give the example, even the cloud-based application, for some application we can access, but some can be excluded based on your design of your company. Okay. So don't be confused here. So if internet access, that you have to think about any destination which are going to the publicly accessible. Means their IP must be the public IP address. Simple definition. Means any URL, any FQDN which having the public IP address which can be accessible by the internet, that is known as the internet-based application. Simple definition. But if I talk about the private access, then my all IP should be private IP. Just an example I'm giving, even public IP could be possible, but private application that should be not be accessible by the public internet URL, and that FQDN should not be accessible by your internet. So that's the private application. So if I want to access my any application which are hosted in my internal data center, my cloud data center, then Zscaler Private Access come in a picture. It having the focus to provide secure access to the private applications. And how it is going to happen? So Zero Trust Network Access, that is again going to leverage this ZPA concept, that again going to operate on the Zero Trust principle, and they are going to ensure that users are granted access only to the application that they need. What does mean? Let me give one of the very basic example so you guys can understand. The very powerful statement, probably it's come in my mind. So what I explain, let's suppose I want to access any application. Let's suppose this application hosted in my data center. This is the user, okay? So if you are going to use the GPA, right? Here GPA is there. So if this user want to access any application, that access is going to allow to just access only that application, not more than that. Let's suppose this is data center. This DC have, this is the switch. Okay, this is a switch. In switch, we have the 3 servers or might be 4 servers. And they have the same subnet IP address. Might be 10.10.10. Sorry for my bad writing. Just bear with me. I'm a very bad writer. 12, 10.10.13. They are the 4 servers, right? They are going to stay in the same /24 subnet, right? So if I talk about the normal routing, so once I use a normal routing, I even deploy the Palo Alto firewall, checkpoint firewall. What is going to be happen? Even I have to create a lot of policies to just control the traffic communication from the one source to another destination. That can be controllable, but you have to do a lot of communication and all. Right? It can be do. If I don't have any routing, I just doing the flat MPLS network, or might be the internet with the default routing. So simply my all subnet is going to be accessible. So even it's a Citrix, this server is for Citrix, this for the SAP, this is for the FTP, And this could be any other, might be what we can just HR portal. So if these users are going to access all IP, all URL, that all are going to be accessible without any problem. This is a traditional way of the working. But if I'm going to use a GPA, that is a zero trust, again, concept is going to leverage. So based on that principle, the access of the application only going to grant it based on the his need. If he is the IT person, he need to just access the Citrix, SAP, not FTP. Then why he needs access to the FTP and HR portal? He doesn't require. So only these two application access is going to be provided to this particular user. So this is a unique feature. Means first GPA is going to be used to access your internal resources. Means any application which are hosted in your internal infrastructure and you want to access that, GPA is going to come in a picture. That is going to give seamless user experience. With the GPA, user can access internal application without any traditional VPN. Means you don't require any VPN. You just have to install some sort of the, this kind of the app in your system. And this is going to give the entire flavor of this particular, VPN solutions. Means this Zscaler client connector must be installed in a PC. And once you install that, it is just going to give the entire communication, right? So this is how it is going to be happen. So this is your Zero Trust Exchange, which is going to access the GPA feature. You have the flexibility, dynamic application segmentation. You can create the adaptive security policies, and then you can protect your all network. So let me quickly go here in this slide. So you can see here how this is going to be look like in the architecture point of view. So if I talk, this is very high level. We are going to discuss in very detail. If you have the requirement, you want to understand each and everything in very detail. So we have the separate courses for this all, like GIA having a separate course, GPA having a separate course, and all are going to give the entire flavor end-to-end process, how the tunnel is going to build, what is a micro tunnel it's going to build, how the GCC app is going to be installed. So everything is going to cover in very detail. So then it is going to give the full flavor, but it is just a high level how it is going to work. So let's suppose this is a client, right? This client want to access any your internal application which is hosted in your AWS cloud, right? Or might be your data center cloud. So what you have to do that, we have the again Zero Trust Exchange, and in this Zero Trust Exchange, you have to deploy the different kind of the what I can say, different kind of the services for the private services, and based on that private services, you are just going to communicate with this all public and private applications, right? Means the application are hosted in the public cloud, the application hosted in the private, that all are going to be accessible. So they are going to build one tunnels from your laptop to your nearest GPA service edge, right? And one tunnel is going to created from your service edge to your cloud connector. We have to use the, like one of the client connector we called in the client connector. So we just have to use the client connector. So one tunnel is going to build between the GPA to the client connector, and they are going to bridge by together by this your service edge. And then you have to create a lot of policies, application connector group, lot of things you have to do, provisioning key, even you have to do that, everything. So you can see and learn how it is going to happen step by step, because we have deployed each and everything from the scratch. So this is how it is going to make the communication. The first user need to attempt the any access the application. If it is going to happen, first thing, user identity need to be checked. Once identity is going to verify, then the next step is going to be happen. Means the third step is going to be happen. Once identity is going to arrive, policy is going to be checked whether this user is going to access this particular application that really required accessible or not. If it is not, then it is going to block. When the policy is going to be checked, it is fine, then it is going to connect to just select that cloud connector which is very nearby to you or as per the policy, and then you have the policy access, and finally you are going to access the applications. All right. So if it is allowed, Zscaler client connector initiate the outbound connection tunnel per app, per application. It is going to build one tunnel, and G app connector initiate the outbound tunnel. One is from PC to this particular GPA services, and GPA services to build the application server, and end to end, service edge is stitch these two tunnel together. You can see here Zscaler service edge is going to connect collaborate these channels together to just exchange the data packet by using the synthetic IP address also. Your not actual application IP is going to be part of this particular communication. So this is how your GPA is going to come in a picture. I hope this is going to be clear to everyone. Now we have the third applications, third platform of the Zero Trust Exchange, that is ZDX. Okay. So what is ZDX, right? That also we have to understand. So if I explain the ZDX, that is the Zscaler Digital Experience, means one of the key feature Zscaler provided and very unique feature I can tell you guys. We have the very good web proxy ZIA, we have the GPA, both we have, right? There's no problem at all. But what about the real-time troubleshooting, right? And how I can quickly fix any issue if the user is reporting. So if I have something which need to be quickly fixed, then ZDX is going to come in a picture. Trust me. And this ZDX is the Zscaler Digital Experience. This going to give you focused and end-to-end network visibility also, right? Let's suppose I have any problem in my network, right? And I want to see what is happening in my network. So it is going to give entire network infrastructure details, from which connection your PC is connected, when client is connected, what kind of the hopes are available, hope by hope, what is the latency we have. And let me show you a little bit. You can understand on the graphical. So you can see they are talking the client connector, means this is the client connector. If client, this is the client connector. Okay, so this I will just only internet access because it's just demo one. But we have the GPA also need to be there. We have the ZDX also need to be there. So let me show you a little bit here. So if I go here, GCC Zscaler, and you just go in the images, you're going to find, see, this is the like something you're going to get. So we have the private access, we have the internet, this only have the internet access. You can see just only the internet security, that is the internet access. But if you're going to full flash, use the GPA, GIA and ZDX, then subscription is going to look like in this way. And ZDX is one feature you have to enable it, ZDX, and then it is going to give the complete visibility of the end-to-end network. So let me just show you Zscaler ZDX. So if I just use any of this particular, let me open this one. Might be they have truncated some information about the hope. So you can see here, right? We have some user, right? And that user is trying to access the any kind of the application. See, so how the application is connected, what is the private IP, what is my public IP, what is my gateway, it's a wired or wireless, what is the latency between this gateway to my user machine, then gateway to the your egress routers, or might be the Zero Trust Exchange, GIA service, GPA service, and then how you are going to reach to the your GIA services, GPA services. So your router might be here, your internet provider is in between, then your GIA, GPA, then you are going to access to the actual application, what is the latency. So end to end, right? The quality is going to be monitored. End to end, your path is going to be monitored. If any application you even want to monitor, right? Real time insight, right? You want to get like application performance analytics. So Zscaler Zero Trust concept, by leveraging the ZDX model, right? It is going to give the entire visibility of the any application. It's a Zoom application, it's a Teams application, any other SaaS-based application. How many latency I have, what is my different kind of the packet loss I have, right? Which node is actually culprit, where I have to hit the right, like concept to just make sure everything is working fine. That is JDS responsibility. So this is going to give the real-time insight, how the network is performing, user experience it is going to give, quick resolution you are going to find, you understand the application behavior, enabling your organization to make informed decision about the IT infrastructure. It's the most important, because you know each and everything, what is the problem happening in my network. So that is also going to give the very detailed understanding. It is also going to give the optimized performance, right? And it is going to ensure our organization that user have the seamless user experience when accessing any application, whether they are in the office, whether they are working from the remotely or might be any hybrid work culture. So this is how ZDX is going to come in a picture. So I hope you understand what ZDX as well. So this is how client connector software must be enabled the ZDX, right? I show monitoring policy configuration is going to be applied. Different your path probe, you have to do the monitoring that must be applied there, right? Always you have to send the metric for the data correlations, right? You have to maintain the data lake. So just to maintain that, like any kind of the communication which is happening, that must be monitored. And every employee, that whatever they are doing, synthetic web probe, critical application web probing is going to be happen. End-to-end device health is going to be checked. Even device posture is going to be checked. Your end-to-end network path is going to monitor, and the probing is going to happen. So this is the key concept of zero trust, right? So zero trust is nothing, right? If you just want to understand in short summary, zero trust is just the model. This is the concept. And by leveraging the different feature of the Zscaler platform, we can achieve this zero trust exchange environment, right? So basically, I believe you guys are understand a little bit more about this zero trust exchange, right? So what we'll do, we'll try to understand step by step each and everything after zero trust, right? How my employee is going to come in office, what are different use case, what kind of application they are going to access, and once they are going to access any application, then how the step by step troubleshooting is going to be happen, right? So if we talk about the digital transformation, right? So little bit we have to look at the new architecture like Zscaler offering the user connectivity, right? And we just think about the step back, right? So look what happened in the industry, right? So we have seen, right, like Cisco was one, and we having the concept of the IP-based connectivity based on the hub and spoke, and network was a very popular kind of a Cisco, right? And then we just migrated all traffic from the back through data center to access any application. This was the second revolutions, hub and spoke, data center going to come in the picture. And then we will build the mode of the firewalls, VPN, concentrator, cattle, and mode security architecture, right? So this is how things going on to just protect your communication, exchange the data information. But what happened in last 1 decade, right? If I talk about, especially during the COVID, if I talk about, so the things has been changed. The things has been completely changed. The post-COVID or during COVID, application has been moved not in just data center, it has been moved to the anywhere. And due to that, whatever we have the different kind of the hub and spoke model, data center architecture, we have the castle and moat kind of the what I can say security architecture, right? That was not enough to protect our network. So how we can accelerate our digital transformation? How we can escalate our performance? How we can escalate our user experience? Then we have to think about the digital transformation. And then we have the zero trust concept in concept come in a picture by leveraging that zero trust exchange concept. Basically, we are discussing this all solutions as the solution and everything. So no worry, we'll discuss more about it in upcoming session. I hope you guys really at least have the basic foundation of the Zscaler. If you have any question, just try to reach out to us, and whatever the best answer we have, we'll try to give you all, right? So we have the WhatsApp number, you can just call us, right? You can just write an email as well if you have any queries. So just you can reach out with the emails as well. Someone is going to reply as well, and you can just fill the forms with your queries. So definitely that is also possible. You can reach out to you, and we'll try to make your query resolution, right? Whatever the best possible time we have. All right. Thank you so much, guys. Have a great evening. Bye bye. Take care.